Energy levels. The chemical principle of excited states and ground states of energy levels is explored further through the theory of the roles energy levels play in allowing ground or excited states to occur. The theory behind these states is dependent on the electron within an atom, absorbing or emitting higher or lower amounts of energy. When the energy is at a higher state, it has absorbed quantum of energy, meaning the electron can move up an energy level temporarily, which produces an emission. When the energy starts to lower in state, it has emitted or used up all of its energy and is returning back to its ground state or lower quantum emission of energy. The Bohr model, first discovered by Niels Bohr in 1913, acknowledged each orbit holds a specific energy due to the number of valence shells the atom held, now called principal energy. If the energy being absorbed corresponds with visible light energy, then varying colours can be identified from the emission producing a colour detected by the human eye. This is further explored when conducting a flame practical test. When different elements are tested with heat, each element produces a characteristic colour, allowing analysis of the concentration and materials of metals to be identified. When the flame test was conducted, accurate procedure steps were followed in place to allow for careful and accurate results to be achieved. After rinsing a spot plate with distilled water, 10 milliliters of hydrochloric acid was measured and poured into a 100 ml beaker. 6 to 8 drops of each solution, as well as 3 samples of unidentified solutions, were placed in separate indentations on the spot plate and labelled to avoid misinterpretation. Once the Bunsen burner flame was adjusted to reveal a colourless flame with a blue inner cone, a test wire loop was placed in hydrochloric acid solution to clean it, and then placed into the flame. The wire loop was dipped into each solution on the spot plate, creating a thin film of solution to adhere onto the loop, then moved to the top of the inner blue flame. This revealed a different coloured flame dependent on the type of solution on the loop. Once a flame colour was recorded, the wire was cleaned in hydrochloric acid and repeated with all solutions, including the unknown samples. Due to hydrochloric acid being a corrosive acid, personal protective equipment was used to reduce risk of exposure. As hydrochloric acid is acidic, any spills made on the skin were washed off with tap water for at least 10 minutes. Being extra precautious when using the Bunsen burner and ensuring the gas was turned on and off accordingly meant the risk of burns were very low. The importance of energy levels, including ground state and excited state, allows humans to determine where excited electrons have gone to and returned from after being at ground or excited states. This is seen especially through electromagnetic radiation, emitted when an electron has absorbed energy, becoming excited, then emitting energy through the electromagnetic spectrum. Humans can view the visible range of light frequencies in the electromagnetic spectrum from flames to even sources like fireflies. Radio stations can be used with AM and FM frequencies of radio waves in the electromagnetic spectrum, and we can even visibly see the UV rays from sunburn, which is the only visible region of electromagnetic radiation detected from our human eyes. Energy levels allowed scientists to first identify that the light emitted from a particular type of atom occurs at varying frequencies. This has allowed identification of radio waves, infrared light, visible light, UV light, X-rays and gamma rays, which all obtain a quantitative amount of varying energy levels in correlation with their energy emitted through different wavelengths and frequencies. Scientific understanding of exposures to certain types of concentrations of energy levels emitted, such as UV radiation, X-rays and gamma rays, and their ability to affect humans in certain ways also provides significance to the laboratory workplace.